solved one little problem of a graph of sine on the board. It's finished. I want to leave it there for a picture. Anyway, I want to explain what we did. We did it really slow, step by step, so I think it can be helpful for your study, for your test, okay? The given problem was, can you turn on the light, please, mister?
On?
On, yes, thank you. Yeah, so they see this. The given problem was y equals 2 times the sine of parentheses 3x minus pi over 6 plus 2. Okay, it's a sine graph, positive sign. Okay, we remember that the pattern of the positive sign goes from the center up and down and up. Okay, we remember the basic formula we use in this course for graphing sine and cosine. So you write it here. I recommend you to do it step by step so you minimize mistakes. The given graph, the given equation or formula goes y equals a times the sine of parentheses bx plus c close plus d. I recommend you strongly to write down, don't just do it in your imagination because it's very easy to make a little tiny mistake. Identify, write down how much is a, b, c, and d. So you write down, really write it down with a pencil, sharpened pencil. Capital A, 2, b, the coefficient of x, 3, c, the number that is being added, negative, because right here you read negative pi over 6. C carries the negative. And D is the number that is alone over there, independent term. Okay, that will be the vertical shift. So once you have identified A, B, C, D, you answer the questions that are given in the worksheet. You answer amplitude, period, phase shift, and vertical shift. Easier ones are amplitude and vertical shift. The amplitude is the coefficient, the absolute value of the coefficient in front of the sign. So it's straightforward, the amplitude is 2. The natural amplitude was 1. Sine original was 1 minus 1, 1 minus 1. This one will go from wherever it begins in a height of plus 2 and then minus 2. That's the amplitude, it's like the volume. And the other very easy number that you can spot right away without any formulas is the vertical shift, is the independent term. This plus 2, it means that you took the original graph and you move it 1, 2 units up. Everything is displaced 2 units. Just like a parabola or whatever, when you add, it goes up 2 units if you add plus 2. So this number is the amplitude and this number is the vertical shift. Really easy. Now we have other 2 little tiny formulas that if you memorize, it's easier and faster for the period and the phase shift. The period will always be 2 pi over b, 2 pi over b. Okay? If your b was 1, 2 pi over 1 is 2 pi, that's your natural period, the original model function. In this case, the p was 3, so the period is 2 pi over 3. You can write it like this. I like writing 2/3 of pi. Okay? Do you have the period? The period is the time that it takes to go all the way up and down and end up in the same position. That's one period, one revolution. Phase shift. Phase shift is desfasamiento. It goes to the right or to the left. The formula for the phase shift is minus c over b. Okay, minus c over b, always. So you have minus, you put the minus right there, step by step. C is negative, negative pi over 6. Eventually, minus times minus will be a plus. Right now I'm substituting. Minus pi over 6 over b. How much is b? 3. So you work out the fractions like in kindergarten, work out your fractions, Sandwich law, and you have that the phase shift is pi over 18. So it's phased pi over 18. With all these numbers, you can build the table and the graph like one by one. Your original point, I recommend to give the x the value of the phase shift, pi over 18, because it begins right there. Your initial point is pi over 18. How high will it be? You can do it with the graph. In the original point, the center will be 2, or you can substitute. If you substitute pi over 18, you will get, you can work this out, that the height will be 2. So your initial point is pi over 18 for x, 2 for y. Okay, and then instead of going point by point, I strongly recommend to go to the very end. Add from the initial point, here, pi over 18, add 1 period. How much is the period? 2/3 of pi. Yeah, so you add pi over 18, initial x, plus the final period, 2/3 of pi. It's adding fractions. What I did is I hid the pi a little bit here. When you add the fractions, 1 over 18 plus 2 over 18, you work it out, and you end up with 13 over 18 pi. That's the end of the function in the first period. So you graph it. How big will the step be? 1/18th, es un 18avo. Partimos el pie en 18avos, and that's how every little step is. So every little line stands for 1/18. 1, 2, 3, 4, blah, 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 and you end up in 13/18. In the end of the first period, the graph will end in the same height where it began. That's what one period means, one revolution. You end in the same position. You begin here, you end here. So you have the first and the last dot. In your table of data, you can write for x 13/18. If you substitute 13/18 instead of x, you should end up with a number 2 for the y. Okay, so you have initial and final. Next step I recommend, figure out the midpoint between 1/18 and 13/18, so you find the center of the graph. Okay, the midpoint is basically the average. You add 0.1 plus 0.2 and divide by 2. I added the fractions. I added 1/18 plus 13/18, that's 14/36, and you simplify, you have 7/18. 7/18 pi is your center. In the sine function goes up and it crosses the center. The center is right here in these two. So it goes up and it crosses the center in the midpoint. Then, just to finish, you calculate the midpoint of the midpoint, like for the first quarter. So you take, we did it really quick right here. Midpoint 2 is 1/18 plus 7/18. 1 and 7 is 8. 1 and 7 is 8. 8/18 divided by 2 is 4/18. So your next point here for the quarter, for the first quarter, is 4/18. Every little line is 18, 4/18. And then this point is in the highest point because you know the behavior of the sine function. And then calculate the midpoint for the third quarter, and it's in the bottom because it goes to the bottom. And then you connect the dots. And do not connect the dots with a straight, pointy, ugly line. It should be a smooth, soft curve. And that's it. Yes, sir.
How do you know the behavior of the graph?
Sure. Thank you so much for that question. By looking at the sine function right here, you can always go back to the very original sine function. If you have only sine of x, y equals sine of x. Sine of 0 is always 0. Because in the unit circle, the sine of 0 is 0. So sine always begins here. And whenever you see sine, it's always going to go like up and down, and it's going to end right here. And in the original, it ends in 2 pi, because that's the original period. That's how we know the behavior from reading sine. If it was cosine, it would look like a U kind of thing. But that's another problem.
Con un punto arriba se va, ¿no?
Yeah, we can pause it now. Thank you. Thank you.